Here's my entry for the Cogswell demo challenge. It involves a Lego Technic truck with a couple of sensors on board. It is attached to a Raspberry Pi with Raspbian installed, Wi-Fi connected in order to broadcast events. Over here is my console. Here's my console for my Raspberry Pi. The host name of that Raspberry Pi is Felix. I'm going to be running the monitor Node.js script on it. Over here is my laptop attached to this monitor, which is named Heinrich. I'll be running the messenger Node.js script from here. The monitor Node.js script watches for events from the two sensors on board the truck and delivers events via Cogswell or into Cogswell, which then interprets and generates messages which are then received via the subscribed WebSocket on the messenger on the Heinrich system, once again on my laptop. So two separate internet connected devices, one delivering the events, that is the Raspberry Pi, and the second receiving them. So I'll go ahead and launch those. The first being the Raspberry Pi. You can see every 500 milliseconds or half second it is monitoring for status events, and then I'll open up and establish the WebSocket, and it got the initial messages. So there were some issues with setting up the campaigns as they cannot be edited right now. So I have one that is causing problems, but everything else works as expected. So every single time we'll see that the driver's side door is reported as closed. That is because campaigns can be saved without any rules, and that implies to our rule system that the campaign should trigger in all conditions, regardless of whether, because there are no rules, it triggers in all conditions. Anyway, I'll go ahead and demo the door opening. This is a magnetic sensor that detects that the door is being opened on the truck. I'll go ahead and show that. Door opened, door closed, door opened, door closed. And then the tilt sensor is a mercury actuated switch. The door sensor was a magnet. The tilt sensor is a mercury bead that rolls when you lift and tilt the truck. You can see the hood being closed. Hood is opened. Hood is closed. Hood is opened. Closed again. So quickly receiving the messages and reporting the status based on the event that's occurring, whether that is the opening of the hood or the closing of the hood. The message indicates that over here. As before, I had mentioned, the driver's side door being closed or reported as closed all the time is something I'm still working out. Here. Observe the hood being marked as open, hood being marked as closed, and that event appearing on the Pi and then being delivered via message to my laptop. Driver's side door open. closed, opened, closed. So in order to connect these, I set up a couple of connections here from the Pi. There are two power rails. The red power lead is connecting over to this rail. That is our 3.3 volt power supply that we're using for both of the sensors. The second one is a yellow one that's 5 volt over to the unused power rail. I then used pin 6 ground and associated that with the 5 volt, and then pin 12 ground was then associated with the 3.3 volt, and that is the ground through which each of our sensors is attached back to the Raspberry Pi. The pins that are actually sensing the data are pins 22 for the mercury actuated switch and pin 32 for the magnetic sensor. Those are attached directly. Initially I had a pair of 330 ohm resistors in place on all of these connections, and later on trim that down to a single 330 ohm resistor. Once again, maybe a redundancy given that some of these sensors have, I think both of these have, yeah, both of these already have a resistor on board, but just to be safe, I placed an additional one which doesn't affect functionality and ensures that you're not going to fry anything or overload the lines on the Raspberry Pi. So probably a good idea. The red lead here and here are the power leads for each of the sensors. The gray lead and white lead are the ground or return lines, and the purple lead passes on from the magnetic door ajar sensor into pin 32, and the brown lead passes from the mercury actuated hood tilt sensor to pin 22. This is a Raspberry Pi, once again running Raspbian. Attached to Wi-Fi via Panda wireless adapter that tends to work well with any Linux distribution I've attempted on the Raspberry Pi. This is a Raspberry Pi 2 Model B Plus board. So it's the quad-core processor with a gigabyte of memory and quite capable. It also has the 40 pin configuration as opposed to the, I believe, 24 pin configuration of the earlier Raspberry Pis. So that is the necessary board, the Pi 2 or above, to use for this setup. These leads have been wired through here, routed underneath and through the chassis of the vehicle. You can see the mercury actuated switch. And on the other side, rotate this, get this into the light. Magnetic coil switch and the magnet that I ripped out of a hard drive. which when in contact or close proximity, either will work, causes the magnetic sensor to trip and send the signal. And upon signal switch, delivers the event to Cogs, which then delivers a message back to my laptop. So there's the unit complete with sensors. Thanks for viewing my entry.